Toyota helped start the electrification revolution in 1997 when it introduced the hybrid electric powertrain and proved its viability for use in passenger vehicles. Since then, Toyota has expanded its hybrid EV range to include multiple vehicles that have sold millions worldwide. Today, Toyota's latest hybrid EV system, also known as the Toyota Hybrid System, or THS, is an evolution of that original series parallel design, where the wheels can be driven by the gas engine or the electric motor, or both, and it's been further refined to provide better performance and efficiency. Above all, the hybrid EV THS system never needs to be plugged in, since it completely charges the hybrid EV battery via engine power or regenerative braking. Plus, its components, including the hybrid EV battery, have been designed with longevity, durability, and reliability in mind. As part of Toyota's Beyond Zero vision for a carbon-neutral future and more, the hybrid EV THS system helps make electrification accessible to all. By choosing one of Toyota's many low and zero-emissions vehicles, everyone can help drive even more electrified miles and help reduce carbon emissions. That's driving change towards a brighter tomorrow, and that's our Beyond Zero vision. With that said, to really appreciate how the powertrains in these vehicles help reduce carbon emissions, it's important to understand what's happening under the hood, learn how they operate, and take a closer look at the entire process from the moment the start button is pressed. Unlike a traditional gas-powered vehicle that cranks a starter motor to get things going, a hybrid EV start button first powers up the system's onboard computers, the electronic control units. Like virtually all automotive systems, these ECUs operate on the 12-volt battery circuit, which also powers vehicle lighting, windows, door locks, and similar features. This explains why you'll find a typical 12-volt automotive battery on every Toyota hybrid EV. Once online, these ECUs check things like the hybrid EV battery status, engine temperature, and ambient temperature. They also manage some of the most crucial components in the vehicle, the system main relays. These relays are next in line and do the heavy lifting of sending hybrid EV battery power to the components that utilize high voltage, and ensuring the battery power is switched on in a safe manner when the vehicle starts, to avoid spiking any element of the system. For safety, if any fault or collision is detected, these relays are designed to immediately power down, isolating the hybrid EV battery while shutting off the high voltage cables, which are color-coded in bright orange. Once the ECUs are up and running, the hybrid EV battery power is sent to the inverter converter. This device controls the high voltage flow to and from the motor generators and the high voltage battery, and maintains the charge on the 12-volt battery anytime the vehicle is running. The motor generators, as the name implies, works as both a motor, providing power when needed, or a generator to charge the hybrid EV battery. Each plays a critical role in how the hybrid EV system works. Motor Generator 1, or MG1, is located directly behind the engine, and when used as a motor, starts the engine on demand anytime it's needed. Because MG1 is much more powerful than a traditional starter motor, it doesn't require a gear drive and is able to start the engine silently. This is the reason you never hear the typical starter sound on a Toyota hybrid EV. Once the engine is running, MG1 is used as a generator and charges the hybrid EV battery. A major key to how the hybrid EV system works is a planetary gear set that acts as a power split device. This is used like a continuously variable transmission to manage the output between the engine and the motor generator 2. Parallel power output from the engine and MG2 work together, or separately, to power the wheels when accelerating and cruising. MG2 also acts as a generator when the brakes are applied or when coasting to capture the energy from the vehicle's forward momentum and charge the hybrid EV battery anytime the vehicle slows down. This two-motor hybrid EV design also takes advantage of Atkinson's cycle cam timing, which essentially means the intake valves stay open slightly longer and create less pressure in the cylinders. This design makes for exceptional efficiency and low tailpipe emissions. But the trade-off is a relative lack of power. That's why it works alongside Motor Generator 2 to produce a combined pool of power, helping provide both exceptional efficiency and good power response, the best of both worlds. So what if you want to make a front-wheel drive hybrid EV an all-wheel drive vehicle? It's surprisingly simple. Unlike traditional all-wheel drive vehicles that use a mechanical drive shaft to distribute the power from the engine out to all four wheels, Toyota engineers simply add an additional third motor generator directly to the rear, right in between the wheels. This explains why it's called motor generator rear. This standalone unit has no mechanical connection to the rest of the drivetrain, but still helps add extra traction, capability, and power at the rear when it's needed. And like MG2, generates power for the hybrid EV battery when coasting or braking. So that's a quick look at the hybrid EV THS system that's found within so many Toyota vehicles. And it's only one part of Toyota's electrification story. Be sure to check out the other videos in this series to learn more about Toyota's electrified powertrains. To explore the full electrified lineup from Toyota, visit toyota.com/electrified.